The World Cup is on, a lot of people are angry and the other half is happy. I'm not too much invested into football, but I saw this picture of the FIFA branding. I like this year's branding a lot. I think it's pretty cool. So I remade this animation in Blender. Well, the animation I don't know actually because I forgot completely about it. But that's kind of like the only logical animation you could make with those layers, I think. So I'm gonna show you how to make that. And you're gonna learn about lighting, about polish, about animation, and let's get going, I guess, because we are in a hurry actually. You know, the finals are today, like literally in 10 hours. I want to release this video before the finals, so we can also make a little prediction who's gonna win. So let's delete all of the objects, let's be quick here, you know, I need to edit this video as well. And the first thing that we're gonna do is this number 26 here. So I'm just going to add any dummy object that contains the geometry nodes, and that's all. Gonna add geometry nodes to the side, add a new geometry nodes modifier, and in here I'm gonna add a node called string to curves, which is the only node you can use to make text. So I'm gonna type here 2, you can see here is number 2, or if I type here 6 as well, it's gonna be 26. Now, you don't have a lot of control over the placement of those numbers, and as you can see, we wanna place them below each other, like vertically. And to do this, we could like use the text box here somehow, like change the width, and like I guess you can do some scaling. This doesn't give us a lot of control. The better way is to just separate them. So we're gonna do 2 as one node, and the 6 gonna be a different node. So 2, 6, 2, 6. I'm gonna join those together. And then, as you can see, these are completely wireframed currently. So it doesn't matter if you render them, we still can't see them invisible. So to make them visible, we need to fill them. So I'm going to take a fill curve node, put this here, and now they are filled. Great. We just need to move the 6 down a little bit, and that's where having 2 nodes helps. So transform geometry and move the 6 down. Alright, that's pretty good. That's much closer to the reference than we were, but the font needs to change as well. Now, I did the heavy lifting and I went through 1001 fonts to find a kind of a similar font to this, and the font turned out to be Vipnagorgiala, kind of an Italian/Indian thing. We're gonna take this bold, and we're gonna put this for the 6 as well, and then move them a little bit closer so they actually look like the reference. That's pretty good. Now, let's tackle the next step here, which is adding the layers. So we got 2 in the whatever form in center, and then we're gonna add layers and successively, sequentially make them larger. To do this, honestly, let's just use this node called the duplicate elements, which duplicates whatever comes beforehand, and like selects a part of the geometry and duplicates this. Now, we don't want to duplicate the points of these letters or the vertices. We instead want to duplicate the instances, because as you can see, our geometry is made of 2 instances. Now, the reason why it's made of instances is to save data. For example, if I type in a number like 22,222, you can see we have the identical number 2 everywhere, so it doesn't make sense to create actual geometry. Instead, Blender has been developed in a way that it creates this single number 2 inside and then references it 5 times, essentially instancing. So that's why we have instances here. And let's add 10 copies, okay? Nothing happens, do not despair, because the issue is all the copies are in the same location. It does work, you can see 2 instances, here we have 20. We have 20, correct. This means we just need to move them out of the same location so we can actually see them. And to do this, let's do just as on the reference. So on the reference, each copy sequentially gets larger and larger and larger. So to make them larger, let's use a node called scale instances. Now, you see here we use transform geometry, which also has a scale input. So your question might be, why not use transform geometry? If we use transform geometry, you can see it has scale, and here we have also scale, and they do kind of the identical thing. The issue is, look at the socket shape of scale instances. It's a diamond. This means it can accept different scale value for each of those different copies, but transform geometry cannot do that. It has this rectangular slot which means only one value ever goes in from here and nothing else. So we really cannot use it. What we need is for the first instance, for example, value 1 and then the value 2 for the second one and so on. And this one we can get very easily from duplicate index. If you plug it here, you can see something is happening. Now, they are overlapping very heavily on top of each other. Let's fix this one as well. But first, let's try to make this a little bit more contained so it doesn't blow up so large we don't understand what's happening. So I'm going to reduce the amount of duplicates to 4. And then I'm also going to take a math node and I'm going to multiply this number with like 0.2. So instead of using the scale of like 0 for the first one and 1 for the second and 2 for the third one and so on, I'm going to instead do like 0, 0.2, 0.4, 0.6, essentially just dividing every number by 5, or multiplying by 0.2, doesn't really matter. And we can see an issue here, which is that the 2's or the additional copies we add, they do work, but the centering is pretty weird, it's pretty off. And the reason is that we are currently in local space, and the local space center is for each letter somewhere defined by the font file, by this vipnagorgialabolds.otf, whatever. So let's turn off this local space. You see it is a little bit better because now the 6 is not using its own center anymore from the bottom here, but instead it's using the actual object yellow.origin, the origin of this plain object here, where we currently have the 3D cursor as well right here. So that's the center where they are radiating or scaling outwards. But that's not good for us because we want the center to kind of be at the center of the text. And that's pretty easy to do. We just need to go to string to curves, alignment, and switch from left alignment to center. So now the text will be centered well. And for this number 6 as well, we're going to go to center and close those panels down. And let's see what happened. Okay, that's what we want. Good. Now, does it look like the reference? They are still kinda looking weird, like on top of each other and whatnot. So to make this more clear, let's do so that the first copy is here, and then the second copy that would be on the exact same location, we raise it up by like 1 centimeter, and then the third one again and again and again and again, and then they will be visible. So for that we can use a node called translate instances, turn off the local space again, we don't need that, and connect this duplicate index to the translation. Now this will be quite weird because the duplicate index is 0, 1, 2, 3, 4, and obviously they just get then such a value gets fed in here, 0 and then 1 and then 2 and then 3. So they get moved by 3 meters on all the axes. We don't want that. Instead, we want to move them only on the z-axis. So let's take this duplicate index, connect this here. What will happen now if you connect here is, for example, like 333 will be here for one instance, or 666 for, oh, that's devilish. 666 for one instance, another one, for each one their own value. And we're going to multiply this with 0.01 only on the z-axis. So if there is like a vector like that, then essentially we zero out those, and this one will become like 0.01, for example. Oh, sorry, 0.06, because they get multiplied. So let's connect this here, put this to a translation, and you can see, okay, that is already a bit better. Doesn't look that weird. But each layer is currently sequentially moving upwards, which is not what we want. The reference is more like moving downwards. I think I don't need to explain why, it's pretty clear. So we go here and we just flip this with a sign, put a minus in front of that, bam, look at that. Now it's pretty much as the reference. Let's go to the top view. You can see, all right, that's pretty nice. That's pretty cool. However, the scaling probably is pretty off, like relations between the spacing and the sizes of stuff. So let's add our first camera, or the only camera actually, to make sure we take a scene and adjust the sizes of things to the scene. So I'm gonna take the perspective camera, turn it to orthographic, because it's motion graphics and orthographic cameras look better in my opinion, at least in the start of the 21st century. Motion graphics tend to use an orthographic camera. If you're watching this 100 years in the future, I don't know what the hell you're using, but I think orthographic is fine, you know. I'm gonna put the scale to like 3, and I'm also gonna enable the dimming of the outside of the camera. And now let's see. So I'm going to add some copies to fill up the camera view, and you can see we have an issue that this here has a gap and this side as well. And that is completely because of our transform node here. You know, if you move this, it goes further away from the center, so its origin point gets shifted, and it starts to have this gap here with each copy a little bit more because it gets scaled up. So let's tune this to be quite close. I think this is pretty good. Now let's see what about the size of the central 26 here. This one is pretty big. It's like almost a third of the screen height. So let's go here. And how do you change that? Well, we can multiply this. We can do like that. But then we have to choose either between the size of the central element or the spacing between the layers, and we want to tune both. So instead what I'm going to do is I'm going to add a value to here. So I'm going to put this to 0 currently, put this back to 0.2, and you can see if we add something, we can change the center but keep the spacing the same. And also you see this weird stuff of like number 26 birthing in the center. That's because the first instance has the size 0 or the index 0. The first duplicate from here has the index 0, and then we multiply it, it's still 0. Now we add something, it becomes visible because it has an actual value. So I'm going to do something, you know, that's too much, 70. So that's better, but you can see the second one is very close to the first one. And yeah, how do we do that? We can do this with the switch node. So we only add a switch here, and we add two conditions. For example, the size of the objects is this system, or it's going to be that. So here it's just going to be 1. But we do a switch that if the what is it? If the duplicate index is equal to 1, then use the second system here, and otherwise use the first one. Well, actually equal to 0, so we can change now the size of the first one. I think this is pretty nice. Let's do something like that. Okay, I think the blueprint is working fine. You can see this looks exactly as it should look. So now let's go and add the colors, because the modeling side is pretty much done. The node tree might be a little bit iffy, you know, a little bit mismanaged right now, but we are gonna get to it, okay? So the colors. So essentially we need a way to differentiate between each layer and then map those differences into colors instead. We actually have a way to differentiate between each layer, and that's the duplicate elements index here. So if I preview the index on each instance, enable the layers, you can see we have something. And if I take a math node and just multiply it with a small value, you know, something like that, you can see we have a way to map a gradient. It's essentially like a little UV map. And yeah, let's use this. To use this in shaders, what we need to do is to first store it as an attribute. So I'm going to take a store named attribute, gonna put this here, and I'm gonna call this layer ID. Store this as an integer, because this is what it is, an integer attribute on each instance, and connect this one here. And now what we can do is just take a named attribute node, select a layer ID, and connect this to the system that we have here, so we don't have such long connections and we can actually understand what's happening. Some people really like to use those connections and draw those lines. I don't like them at all. So this is why I use generally attributes and try to avoid those connections as much as possible. I mean, there is a reason. Look at that. This system is much more clear than what we had before. Okay, now let's add a material, because however much attributes we store, we cannot display them on the screen unless we have material. So here, you can add a material to this object, but this has no effects on the object itself. You can use any color you want here, like blue, because the materials here are only going to be applied to the geometry that the object has in edit mode. And in edit mode, as you remember, we deleted the thing we had. So instead, we're going to use a set material node, plug this here, and we see some blue stuff on the object. Very nice. So let's go to shader editor and let's try to make it not only blue, but all the other colors. I'm going to add a little bit of an extra workspace here for us, image editor, and take the reference and put this here so we can map the colors, pick the colors here. Let's take the attribute that we stored on the object, which was called layer ID. We preview this, we see nothing. That's because it was stored on instances, and we need to switch this to an instance attribute. Okay, you can see it does work. And I'm going to also Ctrl H, minimize this node so it's a small, beautiful one. And now let's add a color ramp, and try to map this, but you see nothing happens. We could map this theoretically to different colors, like the first one, the blue, and the second one, the red. It does work, but obviously the range of the color ramp should be a little bit larger. So to do this, what I'm going to do is add a division node and divide this. And you can see this is how we can increase the range of the color ramp to the range we want. Now, I don't know yet what this range is going to be. Let's first select the colors to the ramp, and then let's deal with this division here. So I'm going to disconnect this and go out of the rendered view. How many colors do we have? We have, as you can see, turquoise, purple, and beige color here. And then if we go forward a little bit, you can see turquoise, purple, and the beige color. So we really have only a small portion of this image repeating over and over again. And we can just copy this to the color ramp and make it repeat, and then it's going to be fine. Then we are good. How many colors we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different colors. Let's add them all. You could use, in some cases, the eyedropper tool and just do that. It works, but it adds a lot of different stops that we don't actually need. Instead, let's add a number of stops manually that we need, which is 13 colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And let's distribute them from left. So now they're all equal here. And for the first one, we're going to take this. And on the second one, we're going to take this. And for the third one, done. Let's switch the mode to constant. So they are all of those colors, and plug it here, and let's preview that. Oh, that's already better than it used to be. And with this division here, we can control like the logic here, I would say, of how large the color range is going to be. And it actually needs to be a little bit below the 13 colors we have, so like 12 and a half. Now you can see we have all the colors here and that we need. We just need to make this repeat. And to make this range here repeat, we are going to take a math node and put it to modulo, truncated modulo number 1. You can see now it starts to repeat over and over and over again. Pretty simple. And if you plug this to the color ramp, bam, now the colors repeat. Without, they don't, now they do. Okay, that's the setup. Honestly, nothing else here, just gonna connect this to the base color. And the colors are pretty washed out. I would say pretty washed out. So let's go to the render settings, color management, and turn them to Chronos PBR neutral, which is what I like to use the best, much more intense. And also turn up the roughness a little bit more to like 0.8. So it really makes the colors pop. Okay, colors are there except for the first one, which is white, and ours is not. So to make it white, we need a mix node, mix color, put it here. With a factor, we can switch to white or not. And I think you already know how to do that, because we can compare if the layer ID is equal to 0, which means the first layer, and mix, and bam, it's done. I'm only going to adjusted the vision here a little bit, and I think this is fine. Yeah, this is fine. So we have the yellow coming right after the white. I'm gonna pump up the white to the max. Done. Colors are done. Now the next step is to compare this to our reference, which we can do very easily like that, and see if there is a difference. I would say generally we are pretty close. Like obviously the font is a little bit different and so on, but it looks pretty fine, pretty nice. And what we need to do now is to set up the lighting, because that's the next most obvious thing missing here. So for that, we're going to use cycles and add a light into the scene. So where are we going to add the light, you might ask? We can just try around, but we can also use a little bit of that knowledge, you know, of that human intelligence. The shadows are a good thing to spot when setting up lighting. And you can see here the shadows go to the left. They go to the southwest and they are pretty soft. This means that the light is large. It is positioned in the top right corner somewhere here. And you can see it has a little bit of like reflections here. So this means we have a light pretty close, a large, probably round area light, pretty close to the camera, pointing at around 45 degrees angle onto our layers. Let's do that. So I'm going to go to the 3D viewport and I'm going to add a light here. A light area. I'm going to add an area light because I need this to be large and have some directionality to it. And gonna change the shape to disk, move it down a little bit, make it larger, and let's actually preview how this looks. This does not look too good. So let's increase the strength to like 100 and maybe 40. And now if I'm setting up lighting, I usually like to set the pivot center to 3D cursor and then rotate around that. So I have a pretty easy way of placing it. I think this angle is kind of fine. And now I'm gonna go to the top and rotate it that way. Okay, let's compare if the two are similar or if they are not. I would say ours, well, I think our background is also, yeah. Ours is a little bit too small, I think. So I'm gonna put the size to like 2.5 meters and try to move it a little bit further away, something like that. Seems okay shadow-wise. The shadows I think are pretty similar now. However, the gap between the layers on the reference is much larger than we have. So let's go back to geometry nodes. Let's select all of the layers and let's go and, you know, this one is what we use. Oh, wow, well, that's cool. That is so crazy. Okay. We need to move those layers down. So I'm gonna increase this to 0.2, maybe 0.25. Yeah, that's pretty contrasty and that's pretty close to the reference. You can obviously tune more, and the file of the original animation you can download as well at badnormals.com. It's like a little premium of this tutorial, so you can see the exact lighting setup there. But I think for now this is fine. The only addition I would make is maybe taking another copy here, like a weak one, like a really not a too strong one, like maybe 20 for the strength. Yeah, that makes it better, definitely. Maybe even 10, you know. Let's see, with or without. Yeah, that's better, I think. Okay, so we have finished the placement and the lighting, and I think we are reasonably close to the reference. Of course, with some extra fine tuning, you can make it your own. So let's animate this, and it's not going to be very hard. The animation is going to be pretty understandable, but motion graphics animation is done a little bit differently than, for example, character animation. So the key thing you have to think about when doing animations for like graphics and stuff, I recommend you do all keyframing, everything between 0 and 1. So it's very easy for you to understand when you want to have the maximum of something or the minimum of something. Let me demonstrate to you. So we have these layers, and what we want to do with them is, you know, open them up and close them down. These are the two states that we need to animate between. So we need a closed down state and we need an open state. This means we are not going to go inside of this scaling system and start to animate those values here, keyframe them, you will just get a huge mess because sometimes you have a lot of values that bring up a state. Instead, what we're gonna do is take a mix node, put this to the end here, and for example, number 1, and now we have a mix between an open state and a closed state, which is much easier to animate than keyframing all of those different values here just to make something, you know, change. And then if you change the look of one state, then you need to rechange all the keyframes. It will be a mess. So instead, we're going to add a mix node for that and mix between those two states. Now I want an open state. This works. Closed state is a bit wrong right now. I think this size should be 0.76. Yeah, close and open. And now what we need to do is to mix between those states based on the layer depth, or like we need to open and close those layers one by one instead of it all happening in the same cone. So this doesn't look too hot, I would say. This looks pretty boring, but we need to do it one by one. For that, we can use the layer ID. Let me move this down because we might add some more nodes. And I'm going to take the layer ID, and what I'm going to do with this now is also map it between 0 and 1, because the layer ID, now if you see from this side, I'm going to show you how you can check that. You know, enable attribute text, turn off color opacity, instance mode, you can see this is the layer ID, 0, 1, 2, 3, whatever, up to 64, which means we have 65 copies of those instances. This is a hard range to work with. So what we're going to do is map this between its minimum and maximum. Now, what we could do is just put 64 here, and that's fine. You go from 0 to 1. If you want to change the amount of instances, you could also use a number called, you could use like field min and max, and this one would give you the min and max automatically. So you can see the min is 0, the max is 64, and then you can connect them here. I'm going to keep them here just in case, so you also see how this could be done. So now we have a range going 0 to 1 from top to bottom. And we can use this, I'm going to enable callouts as well. We can use this for the factor of the state. Obviously, if I do it right now, it would look kind of weird. So it would do something like that, because it starts to like mix and gradually close itself down. We could obviously also invert those. So we have 1 responsible for like open state and 0 for closed state. I think this makes even a little bit more sense. So I'm going to swap the values and connect the factor here. And now you have something like that. This is good and all, but this doesn't help us animate. So I'm going to show you how to animate this and explain this later on. So we have this range. I'm going to add another map range here, like 1. And I'm going to map this from 0 and 0.1 to 1. And now if I move this, if I slide, you can see the animation works out pretty beautifully. I'm gonna increase this to 0 and 0.5, so it's gonna be a little bit clearer. You can see they go one by one, open up all until the end. Okay, these are essentially our two states. As you can see, I drag, this is our first state, and this is our second state. So now we just need to add another mix node to control between those two different states. I'm going to add a mix node, 0, 1, mixing between 0 and 1. I'm just using this for a slider, honestly, from 0 to 1 for a value. And now I'm gonna add 2 more map ranges. You're like, oh my God, map range, I hate this node. Now this guy adds like 4. It's gonna be fine. I'm gonna tell you what it does. So you have result 0 and 1. What are we gonna do with this 0 to 1? So when it's 0, we want it to be 0. When it's 1, we want it to be 1. That's pretty boring. No point to that node, but we don't want that. Instead, when it's 0, we want it to be, you know, at the start of this state here. So we want it to be at like minus 0.5. Okay, let's do that. And when it's 1, which means we are at the end of the animation, then we are going to be at where? Let's see. 1. So currently we are dealing with this from min, you know. So 0.5 to 1. Good. We are mapping this slider's values to this new range of minus 0.5 to 1. You could also use like math nodes, subtracting and multiplying, whatever. It's going to get super complicated. So map range does it much better for you. And then we need to do the same thing with the max as well. So for that, I'm going to add another map range, connect here. And when the animation is at the start, what we want the 0 to be. I don't remember actually. So let's go back. We want it to be 0. And at the end, we want it to be 1.5. I'm just scrolling until I see the animation is in the state that I like. So I'm going to put 0 and 1.5. Actually, these numbers are just this map range plus 0.5. So we could also do that, but it doesn't really matter right now. So let's connect those two here. And now let's see the animation. They close down 0 to 1 and they open up 0 to 1. That's great. And I think by now you are starting to understand the power of using the 0 to 1 animation, because if you were to animate those, here, from minus 0.5 to 1.5, whatever stuff, and then you want to change something, you need to move all those keyframes, whereas right now you just have one, and that's perfect. Your graph editor is going to look so much cleaner than without that. Okay, we have this, and let's say we like that. Also, this adds you the benefit that you can control the smoothing, for example. If you don't like this, I'm going to put this to 0.1 and 0.1. It's going to be super sharp. As you can see, only a little bit of layers move at the same time. With graph editor, good luck doing that. So I'm going to put 0.5 here because that's what I did when I practiced that, and I know this kind of works. That works. One thing I want to change here is the easing. I want to add some easing, and that's again where 0.1 just shines bright. You can see when I start to animate this, I'm going to go to the side here. The new layers just very abruptly move from there here, and there is no easing to how to start the movement. And if you want to add some professional polish to your animations, use a float curve and add some easing like that, because this range is between 0 to 1. It just works out perfectly. We don't need to do anything else. Float curve works. And you can see now when they start to move, it kind of pulls. I mean, you can even see this curve, right? If I turn this curve off, check that. You curve the shape of your animation. Isn't this cool? So yeah, that's how the 0 to 1 animation works. Okay, now we have done kind of enough, and let's actually get to keyframing, because we've been so theoretical so far. So I'm gonna change my keyframes to 30 frames per second. Go to the first frame and maybe wait a little bit, to 15 frames, and start from 1. And then when it's 45, I'm gonna go back to 0. And let's see how this looks. Whoop. You can see like that. And then I'm going to close them down at 75, I mean, the animation itself, you can just do what you want. I'm not going to spend too much time on it because it depends on your wishes and wills, and I have nothing to teach you here. My skills are in the notes section, okay? When the graph comes, I'm just getting by. Okay, so you see, the animation works. It does look a little bit boring though. There is no secondary movement. It only has this first movement of opening up, and that's it. And that's cool. But if you want to add some spice, let's think about the physicality of this. Let's make it have a little bit more life. So when the things open up, abruptly, for example, if I do like that, you see my sleeves, yeah? Sleeves are moving because that's the physicality of this. This has this impulse. Let's do here this animation that I also had in the first one, that they are moving a little bit, and when it opens up, the cards shuffle a little bit. That's super easy to do. So we go just to our translation system here, and we add 2 states again. This is the stable state, and now we're gonna mix this vector with another state. And the other state is going to be cards moving. So I'm going to put this here. I'm going to use the same thing as the bases, no difference. But this time I'm going to add something to this movement. So you can see I can add to this new state, and now I mix between those states. It works as you see. Instead, I'm going to take a noise texture, set this to 1-dimensional to save on performance. I'm going to take scene time, plug this seconds into the W here, and plug the color into the add. You can see now this does like that, then that's not good. You can also see it shifts the object a little bit. That's not nice. So what we do is we subtract 0.5 from it, because by default the range is centered around 0.5. Subtract from it, then it will be centered around the 0 here. Okay, so the offset is going to be equal to the negative side as to the positive side. Works. That's nice. Way too strong. Can turn down detail and the scale also to maybe like 0.2. So that's way too strong. And to change the strength, I'm just going to add a scale node here. And multiply this to 0.1. Just increase the scale. Maybe 4 is okay. I think that's pretty fine. But we now need to make sure that they don't move all at the same time. So to this W here, I'm going to add our beautiful layer index, layer ID. Can put this here, connect this here, add, and now they all move. Look at that, pretty cool. They're like wiggling around. Oh, that's nice. Usually it helps to multiply the number with something random, so it looks a bit better. If you compare, you know, this one versus if I don't do this, it kind of looks a little bit like too organized. That's because the layer ID is an integer like 0, 1, 2, 3, and this makes this noise repeat in a weird way. So let's just add some random number here. Well, actually multiplication would be better. Yeah, now it works. Now we don't want to have this animation on all the time. We only want to add this when the thing gets larger. So we're going to go to the mix here. We can mix between those two different states now. So I'm going to go here, and at frame 15 it's going to be 0. And when it gets open, like around here, I'm actually going to put this to 0 again. And in the center here, I'm going to put this to 1. And look at that. This looks much better from the camera angle. Like, yeah, I think this looks much better. Obviously, you can tune it yourself, and the file is available, but that is kind of how this should work out. And I also added some secondary movement as well, so we can take the mix nodes and essentially duplicate the setup and add some slow general movement as well. So it's going to be this plus something. Yeah, something like that. Turn down the noise scale and put this to 0.02 maybe. Yeah, you can see this is how I added this. All right, that is the animation. Now, a couple of things that make it different from the reference. We have this FIFA image here and the World Cup text. That was very easy to add, so I'm just going to go to the file and show you how I did this. I'm not gonna replicate that, but the animation itself, it is ready. But from the file, you can see how I added those little extras. Although you can also buy the file if you want to support my work here, you know. And FIFA logo 3 was the file. Okay, so as you can see here, I did a little bit more intense animations, but the FIFA logo itself, I just imported an image, Shift A, image, mesh plane, put this here, and the text is a regular text object that I can edit here. 2028 works out. I parented them onto this empty called element root together with those layers. And then using this empty, I can rotate those layers however I want. And this is how the end animation works. If you see frame by frame, it starts to rotate, the layers disappear, and I'm just mixing with, you know, transparency values in shaders, as you can see from the shader editor. Nope. Shader editor here, from 0 to 1 between transparent and emission, and the FIFA text appears, which always was here, but just in a transparent state. And the small dots that I just added for extra detail, you know, the small dots on the surface here, very simple. This is just, where is it? Voronoi texture. Yeah, just a Voronoi texture with a greater than filter on top of it and create some dots. All right, this is it. You know, I'm gonna stop blabbering on that subject. I think you have a good foundational understanding of how to make this animation, and I covered all the subjects that you need. So I still have time to edit the video before the game starts. And I think who's gonna win? You know, let's actually, you know, let's Blender, let us pen. What? English. Let's have Blender tell us who's gonna win. Do something like that. String to curves, Spain. No. Yeah. Argentina's gonna win. Yeah, I'm a little bit biased. I just spent like 3 months there, you know. If you eat the alfajores, you will understand why Argentina needs to win. Alright, I hope you enjoyed this tutorial. We'll see you in the next one. Go watch the World Cup if you like football, and see you at the next one. In the next one, that's the correct proposition.